So far, we have basically covered the basics of what classes are, what objects are, and we have been playing a little bit with how to define classes and how to define objects in Python. We have been talking about the philosophy of object-oriented programming, but I want to say just a tiny bit more. Basically, what are the advantages of object-oriented programming over what we have been using so far, which is sometimes called imperative programming or other programming paradigms, and there are many of those. Well, the first thing that it is important to say is that the programming paradigm that we use, the way we are programming, doesn't limit or should not limit usability or function. So basically, anything that you can do in object-oriented programming, you can do it also in imperative programming like we have been doing. So this is not mandatory, let's say. You could probably live a very happy programmer life without having to learn object-oriented programming. Okay, so that's important. But object-oriented programming is expected to make some things easier. The hope is that object-oriented programming is going to help with maintainability, reusability, and scalability of our code. So because classes are expected to be self-contained and are defined by meaning, but what we are doing instead of how, it should be easier to find errors in object-oriented programming code than in other programming paradigms. Because of the same things, because code is supposed to be more modular, our code, if we do it with the object-oriented programming paradigm, should be better for reusability. It's not uncommon, it happens all the time, that some new data structure or some new algorithm comes about and I want to change my code to use that new thing. In object-oriented programming, if I have done it right, I should be able to just unplug one small part of the code, change it for the new thing, and then keep using the rest of my code. So my code should be reusable also in a new application. If I want to use just a part of the code that I already had, I can just unplug that part and plug it in the new application. And both things help with the scalability. If I want to make bigger applications, object-oriented programming is the usual way to go. Back to what I was talking about, I have more or less covered the basics, and I have defined the init magic creator method, some other set and get methods, and even the string method. So I have defined quite a lot of methods, but I want to speak for the remainder of this session about a couple of advanced issues. And the first one is the issue of method versus function. So not really super advanced, but more advanced than the very basics that we have been seeing so far. Basically, I said before that methods are going to be, for me, the functions that I can use with the objects in my class. And remember that I always had to use them. For example, when I used the if I want to use the get method or any other method of my class, I have to use them related to one object and with this dot notation. So I'm telling, for example, here Python, use the get price method of whatever class this thing is in this ramen object. And then Python very smartly will find where ramen is defined and say, oh, this is of type foodstuff, and then it will take the ramen object, find the class foodstuff, and say, okay, when someone uses which one was it, set price, then or get price in the class foodstuff, then you have to do this, you have to return self price, and then it will go to the ramen object and do this, return the self.price for the ramen object, and it will return the 500. Okay, so these are my methods. And functions, so they are functions in the sense that they have the def keyword here, and they defined some code and so on and so forth. So if I was only looking at this before having started this course, I would think that this is just a function with some weird variable naming, probably because of this self. But now what I know is that my methods are functions that define the behavior of the objects of my class. Okay, so am I not going to use functions from now on? Well, yes, I will be using them, but functions will not be the ones inside of the classes. These are going to be called methods. Functions are going to be outside of classes. And sometimes they might have variables that are, for example, objects of my class. Okay, methods inside of classes, functions outside of classes. And among the functions parameters, when I give them arguments, I might have object of my class, because the main thing that I'm doing here is codifying these classes, these abstract concepts, into something that I can work with, these ideas. I want to work with books, with Pokemons, whatever. So I'm defining a new type of data that I can work with. And one of the things that I might want to do with my new type of data is give it to some function. So here I'm defining a function called best bang for buck that receives two arguments. So I have defined two parameters here, and because I have this get filling power here, and I have it defined inside of the class, the same method get filling power inside of the class foodstuff, I'm going to know that these two arguments are going to be of type foodstuff. Okay, so notice that the def is not inside of the class like these ones are, but it's outside. My class definition ended here. But now, close by to the class definition, I'm going to define functions. I'm defining two of them here that happen to use my class, happen to use objects in my class as arguments. Okay, for example, best bang for buck. What am I doing here? Well, I'm looking at the ratio of filling power and price. Something that has lots of filling power for low price will be very high in this fill ratio. So the best bang for buck function is going to receive two objects of type foodstuff as arguments. It's going to compute this fill ratio for both of them, and then it's going to return something. It's going to return a string, to be precise, that says something like the name of F1 or the name of F2 will fill you more for the same money if there's a difference between the fill ratio of the two objects that I have, or it will just give the names of the two foodstuff that I have received and say they are equally cost effective. Okay, let's see it in action. Here I have defined my ramen and curry and maki and beer. Now I have defined another foodstuff. I can define as many objects of my class as I want to. And I'm going to print best bang for buck for ramen and curry. So it's telling me that ramen will fill you more for the same money, because ramen has 4.5 filling power, which divided by 500 is better than 6.5 filling power divided by 800. Okay. I also defined another function which is called betsu betsu. In this case, what do I have? I have a number of people and a list of food. Okay, a variable named list of foods that's going to contain several foodstuffs. And I'm not going to stop here with this. I'm going to just leave it at that for this moment, but you will understand this much better in a couple of sessions where we will be speaking a little bit more about some advanced programming techniques, and this one is a list comprehension, so you can remember list comprehension now, and just believe me for now that what this Betsu function is doing is computing the average price the sum of the price for all the foodstuffs in my list and dividing it by the number of people. Okay? So this Betsu function receives a list of objects of type of class foodstuff, a number of people, and divides the sum of the prices of all the objects by the number of people that there are. So for example, let's say we go for dinner with some friends and we take a quantity of ramen. Sorry, I said a list of foodstuffs. I should have said a list of tuples of foodstuff and quantity. So let's say we go with a group of friends for dinner and we have 3 ramen, 2 curry, 10 makis, 54 beers, because of course we were there a long time. And then we compute the average of all these things. And in this case, we're going to be paying each, because we were 4 people and had 54 beers, 900 2,000 yen each. Okay, let's suppose we were not so thirsty and only had 5 beers, and then our price would be much lower. Beer is a little bit expensive in Japan. Okay. Basically, I have defined 2 functions, not methods, that use the elements of my class. I went really fast over this one, okay? So one thing that you can do, and I really recommend that you do it, is slowly go over it and try to understand how that works. The list comprehension part, you haven't seen it. You can look it up, or you can fast forward a couple of units until you find it. Okay. To finish this session, I'm going to be speaking about class attributes.